Now we're going to do something a little different and consider something that we call categorical variables. Categorical variables take a value that is one of several possible categories, creatively enough. As they are naturally measured, categorical variables have no numerical meaning. Examples are things like hair color or gender, field of study, college attended, political affiliation, status of disease infection. So what we're going to do usually is compare two of these. So we might consider gender and hair color, or hair color and eye color, or college attended and political affiliation. So we're comparing two categorical variables. The data is summarized in a two-way table. Sometimes you call it a cross-classification. So we say, like, does gender affect what you like to do? Does the color of your eyes affect your ability to bat during day games? It's used to answer questions of comparison. And how we will display this data is in what we call a two-way frequency table. So over here to the right, first of all, let's fix our copies. This is dance and sports and TV. Okay, so the table shows us favorite leisure activities for 50 adults. I can look in my total column and see how many men I had, that would be 20, and how many women I had, which is 30, which gives me a total of 50. I can also look in my columns and see how many total people preferred dance, how many total people preferred sports, how many total people preferred TV, okay? So how we read it is like, if I look at this 16 women preferred dance out of the total 30 women that were participating. So because we're doing a lot of counting and we're counting frequency, we call it a frequency table. And it's a two-way frequency table because I'm comparing men and women, gender, to what they prefer to do in their leisure time. Some more definitions. When we're looking at the total column or the total row, we call those marginal frequencies because they're on the margin. We can also call it the marginal distribution. What is in the body of my table, so it's all this inside stuff here, we call the joint frequency because it is comparing both men that like to dance. So it's doing both of those joints together. If we looked at only the marginal frequencies, then we might conclude that my three activities of dance, sports, and TV were about equal. I have 18, 16, and 16. But if we look at the joint frequencies, there is a strong preference or a strong difference between men and women when it comes to dance. So that's why both of these things can be very important to look at. Whereas I have 10 and 6 kind of close, and then 8 and 10, that's equal. We can also display what we call relative frequencies. Now, relative, that means I'm being compared to something. So how we've gotten all of these numbers over here is we divided each entry in my table, every single one, by the total. I divide each entry by the total. So I'm going to flip back to my other page. To get my top left, I would do 2 divided by, my total is 50. To get this next one would be 10 divided by 50. And then 8 divided by 50. And this is with a calculator, so we just type it in the calculator. So that is how they're getting 0.04, 0.2, 0.16. So I divide every single number in my table by the total. And that mathematically is pretty much the hardest thing we're going to do. And if we're talking about relative frequencies, then we call those conditional. They're conditional on whether I'm talking about men or I'm talking about women. So, for example, a public opinion survey explored the relationship between age and support for increasing the minimum wage. And since my copies again not come out, yes, no, and no opinion. My last one is my total. Okay. The results are summarized in the table to the right in the 21 to 40 age group. So that's here. What percentage supports increasing minimum wage? So I'm not caring about the rest of my table. All I'm caring about is this top row, 21 to 40. And I say, what percentage supports? So that would be yes. So that would be 25 divided by my total, which is 50. And that is half of what I'm talking about, so that would be 50%. As opposed to, I can also say, what percentage of the 21 to 40 group supports minimum wage? What percent of the total is 21 to 40 and supports it? And that would mean I would do 25 divided by 200. That would give me compared to the total. So what I need to be careful of in these problems is paying attention to what it's actually asking me. So another example, and those that are for increasing minimum wage, what percentage were in the 21 to 40? So in those that are for increasing. So I put my little titles again. Those that are for. So I'm looking in this column. What percentage were in 21 to 40? So that would be 25 out of my total 100. So that would be 25%. All right. Which age group has the greatest relative probability against raising minimum wage? So we want to be looking at this part, against, no. Which group is going to have the biggest portion of this? It's going to be this one with the 35, which is in the 41 to 60 group. Okay? So, really, the only thing we're going to need to do, and if you want to just summarize this on the bottom of page 152, is first make a frequency table. So you want to look at variable 1, and then your variable 2 goes on this side, and then at the edge you have your totals for each column and each row, and I get those by just adding. Then I can divide by the total, and that will give me my relative frequency table. What if I wanted to go backwards? What if I'm given the relative frequency table and I actually want to answer questions in terms of numbers? Then I need to multiply every entry by the total. So if I'm starting with the whole numbers, I need to divide. If I'm starting with the ones that are decimals, I need to multiply. And one other thing, I'm going to scroll back to one of these pieces of paper where we looked at the relative frequency table. And let's talk about that some more. Notice in the bottom right, it says 1, because I'm accounting for 100% of my data. So just to go over one more time to read this, if I'm looking at this point 12, that means that 12% of women, 12% are women who prefer sports. 12% of my group are women who prefer sports. The 32 means that in my respondents, 32% are women who prefer dance. I can compare it to all of the women. I would do 32, let me do that in a different color. 32 over 0.32 over 0.60, that would give me the percentage of only women who are preferring dance. So you have to know, am I comparing to the total or am I comparing to just one row or column? So let's write a little note for ourselves. I'm going to do that in red because it's really important. Are we comparing to total or just one row or column? Okay, so review those last two things that we wrote outside of the notes, and that's how we're going to be approaching the problems. Once again, just to sum up, we need to make a relative frequency table, which you do by putting your categories for variable 1, your categories for variable 2. You find all your totals by adding. If I want a relative frequency table, then I would divide by the total. If instead I'm given the relative frequency table, I multiply every entry by the total. And when I'm answering the actual questions, I need to make sure, am I comparing to the total or am I just comparing to one row or column? Okay, that's it. Have a good weekend and make sure you work on your project because it's due when you get back.